With the constant current mode just about there, I want to get a bit of a temperature correction going and get the other three modes operating. I don't think the constant voltage and constant power will be much of a problem. Constant resistance, on the other hand, I have a feeling when I get to that I'm going to wish I had used a processor with hardware floating point math, but I'll find out in a bit. Now I have changed the ADC operation. The digital filter has two modes of operation, averaging and oversampling. I had been using the averaging, but I thought now with good clean power supplies, and best I can tell, seems like random noise on the voltage and current input signals, would be a good time to try the oversampling mode. The ADC clocks are set like this, same as I was using for the averaging, so I have an ADC conversion time of 330 nanoseconds. So I have the digital filters set to 32 times oversampling, and I have the conversion delay set to 54 TAD core clocks. That should give me a sample time of about 1.08 microseconds. Should be able to get almost 23,000 filter results per second. So I have the ADC trigger clock set to just a little over 22 kilohertz. So the samples should be spread out pretty evenly over time. The 32 times oversampling will give me a 15-bit result in the filter data register. I'm going to just discard the least significant bit, so I'll be working with a 14-bit value for the voltage and current. I've got this bit of code to try and deal with the constant current initial error and temperature drift error. It really will adjust quite slow as it's only called every 200 milliseconds. I've got a section in the code to try and keep it from oscillating back and forth. If it moves in one direction, the error amount has to get pretty high before it can move back in the other direction. And here's an example of that. I'm at a 20 amp load here, right close to 400 watts. Of course, the meter on the left is reading about 4.25% low for the current. But can see it corrected at the very start, and then it had to get, well, it's right around 70 milliamps error before it would correct back the other direction. Not great, and if I get the time I may rework this section, but I can live with it just like it is. Here's the current waveform at the load terminals. The fact that I'm not getting any oscillations makes me very happy. And this supply voltage has a very large 120 cycle ripple on it as well, and I don't even see that in the current waveform. Very pleased with that. I'm going to consider constant current mode working, with some tweaks here or there in the future. The other three modes work in a completely different way. All the control has to be done by the microcontroller. The constant voltage and constant power are pretty simple right now. I see how much error there is, and if it's over a certain threshold, I adjust the DAC value. I have the amount that the DAC can be change clamped. Right now it's set to a little over 1 amp a millisecond. Still worried about oscillations, so I'm thinking that will help stop any wild swings, but it also limits response time. The constant resistance mode is still giving me some trouble. It wants to have a bit of ripple at a higher resistance setting. I think that may be just the coarse current stepping of the output. If so, it may only be usable at very low resistance settings. It has worked fine on the DC power supply, but that can only supply 5 amps, so I want to test it at a higher current and see. So I've got a small lead-acid battery to put on the load. Should have no problem supplying 10 amps. The yellow waveform is the current from the lead-acid battery. Blue is the AC voltage on the load terminals. And this is in constant voltage mode, with the voltage set low enough to pull about 10 amps. The yellow current waveform will represent about 1 amp per 100 millivolts. Here's the constant power mode. Had to set it to about 112 watts to get 10 amps flowing, but it looks good. Not oscillating, and that's what I want. Now constant resistant mode, with the resistance set to about 1.1 ohms, again 10 amps flowing. Now it looks nice and flat and beautiful, but here it is at a 4 ohm setting, about 50 millivolts of 500 cycle ripple, around 500 milliamps peak to peak. So I've still got work to do on this mode. It may have to do with my math. If it was the coarse current stepping, I don't think it would get to the half an amp ripple level. The DAC value must be changing by about 20 to give me 0.5 amps of ripple. That's got to be a code problem I need to fix. But what happens when there is a large ripple on a DC voltage, like a power transformer, bridge rectifier, and capacitor setup? Which is what I have here. The power supply is unregulated, at least it is now, and can supply 600 watts, though the terminals start getting pretty warm at a little over 500 watts. So here it is in constant voltage mode. I've got the load set to 23.7 volts, 150 to 200 milliamps of load. But as can see in the current waveform, it's trying to adjust to the voltage ripple, even with the ripple barely over 200 millivolts. Here I have the voltage set to 20.8 volts, right around 10 amps of load. And I think this is a very interesting waveform. I have a little over 2 volts of 120 cycle ripple. At the same time, I've got about 5 amps of current ripple. The update routine is running at around 5 kilohertz, so that's about 41 updates per one cycle of the ripple. And you can actually see the steps in the current waveform. Here at the current peak, can see that it is just barely affecting the voltage ramp. I think that tells me the caps in the power supply are still in very good shape. Other than the caps info, it also tells me the clamp in the constant voltage code section is hard at work. I'm going to up the clamp level, bump it up to around 10 amps a millisecond, just see what kind of effect it has. Two volts of ripple is about 10% of the total voltage, so it will have a large error amount. Well, that's an ugly waveform. First, the current waveform is now at about 10 amps of division, so close to 25 amps of ripple. I think I'm getting very close to being unstable here. Each cycle is not symmetric, and I see that as a problem. Also, for some cycles, the load is off for over 2 milliseconds. That is a problem. This is enough current to distort the voltage ramp. And if I were to remove the clamp altogether, I could see the load being turned on full tilt for some time interval, and it would probably end up blowing the fuse in the power supply. I see the constant voltage mode being a problem with a DC supply with really much ripple at all. At least with the current rate clamped pretty low, I don't see it destroying anything. I'm not sure how to be able to deal with a transient event and ignore the ripple. It's like I will need two modes for the constant voltage. One that just does a slow average to just average the ripple, and then one that can respond to fast events. Something I'll have to think about. Here's the constant power mode, set to a little over 200 watts. About what I would expect. I'm guessing I'm over-adjusting a bit, causing the little bit of ripple in the current waveform, in what ideally would be a mirror image of the voltage ramp. But not bad, I can live with that. And lastly, the constant resistance, set to a little over 2 ohms. That is really what I would expect to see. The current change clamp in the constant resistance code is set very low, less than a half an amp a millisecond. I think that's why the current ramp is kind of flat with rounded edges. Again, certainly can live with this. Problem is when it gets above 4 ohms or so, starts to get a bit of current ripple. It would be nice at this point to say the 3 extra modes of operation are working as I would like. They're not though. Constant voltage, the more I think about it, the more I think I'm going to need 2 CV modes. Really, the more I think about it, I kind of wonder what I would really use a constant voltage mode for. Maybe to act like a battery to test a battery charger was really the only thing I could come up with. I'm going to contemplate about the CV mode before I do anything else. It may be I'm just wasting time on it. If you've used an electronic load in the constant voltage mode, if you wouldn't mind, I would like to know what it was used for. Thanks in advance. Constant resistance, I've got to rethink how I've implemented it. It's messy and there should be a better way. I don't like the fixed point division in the control loop. I think therein lies a lot of my problem. If there were only more time in a day. Thank you for watching.